Today we will learn uh, reactions. We will learn reactions in organic chemistry. Okay, so we will see here that what type of reaction occurs in organic chemistry. So first of all, that we will see the reaction of alkene. So we have the number one, the reaction about alkene are the reduction. Okay, reduction of alkene, alkyne, and benzene. Okay, and benzene. So here we will see that how alkene, alkyne, and benzene that they are reduced in the presence of a suitable reducing agent. First of all, that we have number one, we have CH2 double bond CH2. This is ethene. Okay, and this is reduced in the presence of hydrogen. Okay, and the nickel is used as a catalyst. So what will happen, you can see here that we have the two atom of hydrogen. So one atom of hydrogen will attach with this carbon and another hydrogen atom will attach with this carbon. So product will be CH3 single bond CH3. So this is the ethene and this will be the ethane. Okay, so this is the ethene and this is the formation of ethane. Another we have CH3 CH2. Okay, CH, this is double bond, this is CH2 and this reacts with the hydrogen in the presence of a nickel, and approximately that we use temperature 250 degrees Celsius. So again, this is a double bond between this carbon and this carbon. So therefore these two hydrogen will be attached with this carbon and this carbon. So product will be CH3 single bond CH. Okay, so then CH2 and this will be the CH3. If we have, for example, if we say that we have ethyne, for example, we have the ethyne, this is CH, okay, triple bond, this is the CH, okay, when it reacts with hydrogen. So here we will take the 2 moles of hydrogen, and again that we have the same catalyst, this is the nickel, and temperature will be the 250 degrees Celsius. So you can see here that we have the 2 pi bond. So for reducing the 1 pi bond, 1 mole of hydrogen is required, and for reducing the 2 pi bonds, so we have requirement of 2 moles of hydrogen. So this will be like this one. This is the CH single bond. This will be CH. Okay, they are the 4 hydrogen. Attach one hydrogen here. Attach one hydrogen here. Attach one hydrogen. Okay, here attach also one hydrogen here. So when this ethyne is reduced in the presence of hydrogen, so there is a formation of ethane. Okay, uh, now we have another example of uh, acetylene when it reacts with hydrogen. For example, if I say that we have, this is the CH, okay, this is a CH, okay, so we call this is a acetylene and it reacts with the hydrogen, and you can see here that we are changing the condition. So we use here the Linder catalyst. This Linder catalyst, naturally this is a palladium, okay, and this is a barium sulfate. So this is a Linder catalyst, and along with the Linder catalyst, we also use the quinoline. Okay, so we use the quinoline. So what will happen? that in the presence of this Linder catalyst, only a one pi bond is reduced, not two pi bonds are reduced, only one pi bond. So this the product will be CH2, this will be double bond CH2. So again, this is the formation of ethene from the ethyne. Okay, let's take another example. If I say that I have this a benzene, okay, so this is a benzene, this is a double bond, this is a double bond, this is the double bond, okay, so this is the double bond. Uh, when this benzene, okay, is reduced, okay, in the presence of hydrogen, and the catalyst is a nickel, and the heat is required. So again, we have formation of this a cyclohexane. So this is a cyclohexane molecule. So there are the total 3 pi bonds. So for the reduction of 3 pi bond, we required only 3 moles of hydrogen. Now you can see here that if we use cyclohexane, for example, you can see here that I have this cyclohexane. Okay, this is a cyclohexane, and this is a pi bond, okay, present in cyclohexane, and this is hydrogen. When this is reduced, so again you can see here that we have the formation of a cyclohexane. So this is a cyclohexane. Okay, now uh, if we reduce the haloalkane or aryl halide in the presence of hydrogen, okay, using the different catalysts, for example, palladium, zinc, and plus hydrochloric acid, or the red phosphorus. So we have also the different product. Now you can see here, for example, a reduction of, you can see the reduction of, okay, reduction of, we can see that's a reduction of haloalkanes. Okay, reduction of haloalkanes and aryl halides. So we can see here that how haloalkanes and aryl halides they are reduced. Now let's discuss. We have this molecule CH3, CH2, and this is the C. This is ethyl chloride. Okay, this is ethyl chloride. Now this ethyl chloride in the presence of hydrogen gas. Okay, so we have to heat this in the presence of this is the palladium. So there will be the formation of ethane, and plus one chloride will be removed from this molecule and hydrogen from this hydrogen. When they both will react, so they will form the HCl hydrochloric acid. Okay, if we see that we have C2H5, and this is a bromide, this is ethyl bromide. Now in the presence of this hydrogen and using a zinc and HCl is a catalyst, so we have the formation of C2H6 ethane, and plus we have the HBr. So either that we have the zinc HCl or we have the uh, palladium. They both reduce these alkyl halides into their respective alkanes. Taking another example, you can see here, if I say that I have CH3 and this is a CH2, okay, and this is Br, this is the ethyl bromide, and it reacts with hydrogen, okay, so in the presence of this is the zinc and copper. Uh, along with the zinc and the copper, ethyl alcohol is also required. So what will happen? That bromine from this and hydrogen from this, they both will react. So they will form HBr, okay, and plus one hydrogen, this will be added with this carbon. So this will be CH3 and single bond, this will be CH3. Okay. Again, we have another very important reaction. For example, if I say that I have CH3 and CH2 and this is I. So this is ethyl iodide. Now if ethyl iodide is made to react, okay, with Hi, hydrogen iodide, and in the presence of red, okay, in the presence of red phosphorus and some heat is required. So what will happen? So this reaction will be CH3 and CH3. So this reaction will produce this product ethane, and here will be the formation of iodine. So this is the formation of iodine. So whenever we have the hydrogen iodide, if hydrogen iodide reacts with this ethyl iodide, so this iodide from this molecule and iodide from this molecule, they will both react together to produce this iodine. And this hydrogen, actually we are seeing this hydrogen, okay, will react with this CH2, okay, so there will be formation of ethane.